Three more things to teach today. You'll be done with new content by the end of the week, and then you'll have your in-class practice test for marking on Tuesday of week 7. I'll mark that, give it back to you by the Thursday. You'll have a second sort of formative warm-up test before the actual exam, Tuesday of week 8. I've said that already, I'll say it again. So you're familiar now with our model of exponentials that we use. Y is equal to a times by b to the power of x. A is the y-intercept of the graph. Today's lesson is about how do we draw exponential functions, because it's not as easy as linear, because linear was you put a dot at the y-intercept and then you just did the slope, you went across by how many and you went up or down by how many. Here, it's curved. So it's not as easy. There's more steps to it. So how do I just imagine an exponential function? A is the y-intercept. That's the only definite thing that you can read off straight away. The other thing that we know is exponential graphs always get closer and closer to the x-axis, but they never touch it. So all exponentials, you'll have some that go upwards like this. So on the left-hand side, it'll always get closer and closer to the x-axis, but never touch. Some exponentials, they'll go down like this. They'll get closer and closer to the x-axis, but never touch. The other thing that you'll notice, if this number here is more than 1, it goes up to the right. If b is less than 1, then it goes down to the right. I'll give you some time. Can you get that first general gist of the shape of exponential functions to start off with? I'll move it down so the people that were here earlier can start getting the actual steps to drawing them.
Anyway, these, when you get to a graph up and if you need anything heavy, then I'll be around. So this is good for maybe that box of gloves.
Well, if I can put all of it on here, just roll it up. This is borrowed from,
It's the best thing I've always used.
The lesson blanks are on Dame up now.
No. You can, yeah. These are okay, but I mean, I've often thought about putting a big chunk of that rubber at one. It's a lot easier.
You guys remember where I planned for us to be Thursday in week 8? Are we going to be in here?
No.
We'll try to go to GD previous room.
GD previous room.
Should we go girls' suites, boys' savory? Is that what you guys used to do? I got the sweets anyway. That bag's ridiculous. All right, we'll go through the steps and then I'll demonstrate drawing those graphs with the steps. Step 1, plot the point. Put a dot, whatever A is, on the y-axis. Step 2, look at B. Decide if it goes up or down as you go to the right, but don't draw it yet. You're just keeping that in mind, which direction it's going. But now, step 3 is the one that takes some labor. Make up a table of values for x and y, like this, to plot your points. To curve through, your table of values should have enough columns to fit values from 0 to 4. As long as you got 0 to 4 there, you'll be fine for the exam that I'm running with you. Once you've drawn that table, sub those values of x, 0, 1, 2, 3, 4, into the exponential function, find y. Put these into the table, so you'll have a bunch of coordinates like this. You can plot those dots onto the axes, and therefore you have a nice little scaffold to draw your curve through. The only way that you could stuff that up is if you did straight lines between the dots. I've told you constantly it's a curve. So you just want to draw the curve through the dots. I don't want a dot to dot of straight lines. So get those steps down, and then we will see how it's done, okay? Four minutes, and then I'll demo those steps for you. Two more. And demo. You guys all know the library's closed. It's like legit closed, not just school closed, it's closed.
Why?
I think it's asbestos. I think it might be asbestos. It's bad. In the old days, because they didn't have science back then, they used to make the panels out of asbestos because it doesn't burn. But yeah, it's the fibers, if it goes up in the air, if you breathe them in. So I'm keeping you there. Although that's starting now with silicon, that some people have kitchen benches. That's fun. He's only been funny to himself. Got a distinctive high voice. Oh no, it's deeper than it used to. Now let's demo a little bit of that. I've been asked to graph y is equal to 0.5 times by 2 to the power of x. Which of those numbers is a? 0.5 or 2? Which one is a in the middle? Look back up here. Which one comes first? 0.5 is your A. Your B is 2. So plot a point on the y-axis at A. So A is at 0.5. It's half, so it's down here. Step 2, look at B. Decide if it goes up or down as you go to the right. Is B greater than 1 or is it less than 1?
Greater than.
So we know in the top of our head that this is going to curve up to the right if you're doing it correctly. It's like a self-check. Draw a table of values that's been drawn for you already. Now you're just going to substitute. So substitute y, x is equal to 0. So y when x is equal to 0, 0.5 times by 2 to the power of 0. What is anything to the power of 0? 1. So it's going to be 0.5 times by 1. So it's going to be 0.5. That's why we did a dot on the y-axis is 0.5. Double confirm. Substitute x is equal to 1 into it. 0.5 times by 2 to the power of 1. What is anything to the power of 1?
0. No, by itself.
Itself. So it's going to be 0.5 times by 2 to the power of 1 itself. 2. What's 0.5 times by 2? 2 halves is going to be 1. So I've got another dot that I can place. I'll just fill in the table though. Y when x is equal to 2. 0.5 times by 2 squared. 2 squared is? 4. 0.5 times by 4. 4 halves is going to be 2. Y when it's 3. 0.5 times by 2 to the power of 3. 2 to the 3 is going to be?
6.
No.
Or 8.
Oh, guys, just let me confirm on YouTube. These are year 11. 2 to the power of 3 is 8. 0.5 times by 8 is going to be 4. And then last one, y to the 4. No, sorry, y with x to the 4. 0.5 times by 2 to the power of 4. What's 2 to the power of 4? Let's try. Yeah, that's better. Okay, you redeemed yourself. 0.5 times by 16. Half of 16 is 8. So I have a bunch of coordinates I can plot. 0, 0.5, 1, 1, 2, 2, 3, 4, 4, 8. People are still copying down, so I'll plot what I can. 4, 8. I'll make this smaller. Four, 8, 3, 4. Two, 2. 1, 1. Are those dots forming a straight line?
No.
Are they curving up to the right as expected? Okay. The only way that you're going to stuff this up is if you did straight lines between them. That's wrong. Do a curve. Just do a curve. Oh, Jesus. Let me try my hand-eye coordination as a 40-year-old man. Yeah. I'm not going to get like a protractor out and go, it must be freaking smooth. Show me that you attempted to get through those and that it's smooth. Okay? So get that left one down. Okay. I'll go through the mathematical process of doing the right one without saying anything. So y 8 times by 0.5. So there's going to be a dot at 0, 8. A here was 8, so that double confirms. We should put a dot on the y-axis at 8. B is 0.5. According to our rules before, if B is less than 1, what way is it going to curve? Is it going to curve up to the right or down to the right? Down to the right. So I can check for myself if I'm doing the maths right. It should make points that go down to the right. Okay. Y when x is 1, 8 times by 0.5 to the 1 is going to be 8 times a half is going to be 4. Y 2, 8 times by 0.5 squared. 8 times by a quarter. That's going to be 2. Y when it's 3, 8 times by... Someone with a calculator. Louise, could you work out what 0.5 cubed is? I didn't say his name. Don't you have like an AirPods Max that you can calculate or something? Isn't that what that does?
1255.
125.125. And what's that times by 8?
1.
0.5 times 0.5 times 0.5 times by 8. Yeah, it's 1. Good. And y to the 4, 8 times by 0.5 to the 4th, 8 times by,
0.066.
yeah, 0.0625. That's going to spit out a half. So 1 and 0.5. I can plot those dots there. 1, 4, 2, 2, 3, 1, 4, a half. Is it curving down to the right?
Yes.
So just just make sure it doesn't touch the x-axis. That's how you draw exponential functions.
Cool.
Stop it there so you can chat.